Now let's try to understand and solve the problem arranging of the coins. So the problem statement says that you have n coins and you want to build a staircase with these coins, and the staircase consists of k rows where the ith row has exactly I number of coins, and the last row of the staircase may be incomplete, and given the integer n, return the number of complete rows of the staircases that you will be building. So remember that we will be given n number of coins, and these n number of coins we need to construct a staircase. So in that staircase, the rules that we have gotten is every nth, let's just say every ith row of the stair will consume I number of coins. So that is the principle that we have here. That means there is a possibility that with the given n number of coins, whatever the last row that we fill, that may get filled with that may get filled incompletely. That means that whatever the number of coins that we would want to fill in that row might not be available. As a result, it might be partially filled, but our aim is to return the last row, basically the last step till which we have successfully filled the rows. That means that the partially filled row can be excluded, and we need to return the exact row till which we have filled the steps completely. So that is the problem statement that we have gotten. So if we want to get better understanding, let's look at some of the examples so that we will have whatever the doubts that we may have in our mind may get cleared after looking at these examples. So here the number of coins that we have gotten is 3. So with these 3 coins, what are the number of steps that we can fill, right? So here the first step will consume 1 coin, and the second, after consuming 1 coin, how many coins we still have? 2 coins. So those 2 coins we can put on the second row, because second row anyway consumes 2 coins. So here the total number of steps that we can arrange the given coins in is nothing but 2. So the output that we should return will be 2. If we look at the other example, the total number of coins are 5. So with these 5 coins, in the first step we can put 1 coin, in the second step we can put 2 coins. Overall we have consumed 3 coins, and on the third step we need 3 coins, but we still have only 2 coins. So on the third step we can put the remaining 2 coins, even though it requires 3 coins, but we have successfully filled only the first 2 steps of the staircase. That is the reason why here the output that we should return will be 2 only. So whatever the partially filled step that we have, that we will be excluding, and whatever the completely filled last step that we have, that number we need to return. If at all, if you take this third example, right, so the total number of coins that we have gotten is 6. So on the first step 1 coin, second step 2 coin, and we have consumed 3 coins so far, and we are about to go on to the third step, and the number of coins that we have also 3. So after filling these 3 steps, we still don't have any number of coins. So the last row that we have successfully filled with the given coins is nothing but 3 itself. So the output is 3 here. Okay, similarly you can go ahead and try to understand the case with the value 10. In the first step 1 coin, second step 2 coin, third step 3 coin, 6 coins are consumed. We are about to go on to the fourth step, and we have 4 coins. So total of 10 coins. So the output is nothing but 10. If at all, if we had gotten 11, we still would have had 1 coin, and 1 coin would have been kept on the fifth step, but till fourth step only completely got filled. So we would have returned 4 even in that case as well. Okay, so ultimately the partially filled row should be excluded, and whatever the last row that we have filled successfully, that last row number needs to be returned. Alright, now that we have understood the problem statement, let's just quickly go ahead and try to understand how can we solve this problem with the brute force approach. So here we will be given n with some number of coins, let's just say 10 or something, and in each and every step we will be consuming whatever the step number that we have, that many number of coins that we will be consuming. In the end we will need to return the level, right? So for that, what we can do, we can ultimately, if we want to solve this problem, let me just rearrange this clearly and make it 100%. Yeah, so what we will do, we will simply write one function called arrange coins. Okay, so what it does, it will take the value of n from us. Immediately what we will do, we will define one variable called level or row, whatever you want. Let's initialize it with 0. Every time we fill a complete row, we will update it with, okay, that particular value. Now immediately what I will do is, for int I equal to 1, I will be starting from the first step, right? Obviously that is the reason why here I will start from the first step, and we will be running this loop as long as we have number of coins still available. That means that n is greater than or equal to the, I that we are at, and in each and every step we will be incrementing it by 1, because once we fill the step completely, we need to move on to the next step. So the step index is nothing but I, right? So we will be incrementing it by 1, and this is an important check here. We will only be able to fill that row if we have ample number of coins that we would need for that specific row or step. That is the reason why here, whatever the n that we have, if it is greater than or equal to I, we are good, we can move on to the step. So immediately what I will do is, here whatever the level that we have, I will be incrementing it by 1. Immediately, since we consumed I number of coins for the current step, what we need to do, whatever the total number of coins that we have, we should be decrementing the coins that we have consumed so far. So n is equal to n minus I. Okay, that's it. Once this for loop is done, whatever the row that we have filled successfully on the staircase, we will have inside this level variable, and we can return that level as output. Okay, so this is the brute force solution for finding the last state till which we can arrange the given number of coins. Okay, so this is the brute force approach. Now the number of iterations, we can't say it is order of n or anything, but it is completely based on the number of iterations, right? But we can even bring down the number of iterations that we would need for finding the level that we can fill. We can employ the binary searching technique and find the effective staircase that we can fill the given coins with, very effectively, basically bringing down the time complexity. Okay, now let's try to understand how can we apply the binary searching technique for finding the last staircase that we can fill successfully with the given number of coins. So let's just say the given number of coins are, let's just say 10. So in this case, whenever we want the binary searching technique, what we will do, we will basically have to have the start index and end index, that is the range in which we will search by calculating the middle, right? So here, whenever we are trying to employ binary searching technique, what we will do is, we will start from 0. That means whatever the start that we would want for binary searching technique, we will be starting from the 0 and till the given number itself. So 0, 4, 5, 6, 7, 8, 9 and 10. So this will be our search range in which we need to search the value. Here if we take the indexes are same as that of the numbers, right? So I will not be writing the indexes once again. Now immediately let's just go ahead and calculate the middle. Start plus end divided by 2. So 0 plus 10 by 2, which is nothing but 5. And one more thing that I want to mention is that here in this binary searching technique solution, whatever the value that we want, means the step that we would fill successfully with the given number of coins, we will only be returning after searching all the possible ranges. That means whatever the looping statement that we will write, right? After searching through all the possible ranges, in the end, whatever the end that we have, right? This end will basically be pointing to the last step that we will be filling with the given coins. Okay, so that is something that we need to remember. But anyway, here the middle is nothing but 5. Immediately, what we want to do is, till this middle step, what are the total number of coins that are consumed, which is nothing but 0 plus 1 plus 2 plus 3 plus 4 plus 5. Okay, in mathematics, what happens is, the sum of all these numbers from 0 till that number is called as sum of the natural numbers. So for this, you don't have to write one more for loop for finding the sum. There is a mathematical formula that is nothing but n into n plus 1 divided by 2. So this is the mathematical formula for finding the sum of all the numbers from 0 till the given number n. So here n is nothing but 5. So sum of this will be 5 into 5 plus 1 6 by 2. That means 30 by 2, which is 15. So if we want to fill till this fifth step, we would be needing 15 coins, but the coins that we have gotten is 10 itself. That means the last step that we might be able to fill will be on the left of the middle. That means till middle minus 1. So in this case, what I will do, I will simply update the end to the middle minus 1, which is nothing but 4. Again, I will calculate the middle, 0 plus 4 divided by 2, which is nothing but 2. So here the middle is 2. Now again, till second step, I will calculate what are the total number of coins that are consumed. So 2 into 2 plus 1, which is 3 by 2, which is nothing but 3. So here till second step, the coins consumed will be 3, but we have 10 coins. That means the total number of coins that we have is more than what we would be needing till second step. That means that there is a chance that we can fill the next step also. In this case, whatever the middle that we have gotten, after that the last step will be there. So immediately start whatever we have, I will be updating it with middle plus 1. So here start will be at 4, end will be at 4 and start will be at 3. Again what I will do, I will calculate the middle. So 3 plus 4 by 2, 7 by 2, which is nothing but 3.5. If we round it down, we will get 3. So middle is also at 3. Now till this middle, that means third step, we will calculate what are the total number of coins consumed. That means 3 into 3 plus 1, 4 divided by 2. So the total number of coins consumed till the third step is nothing but 6. So here immediately what I will do, the total number of coins that we have gotten is 10. That means that the last step can be after this. So immediately after the middle, so immediately what I will do, I will move the start to middle plus 1, which is nothing but 4. So at this point, the start will be moving on to pointing to the same index. Okay. Now we will run the binary searching technique as long as start is less than or equal to end in this case. So immediately both of them are pointing at the same index, 4 plus 4 divided by 2, which is nothing but 4 again. So the middle index is also same. So till this middle index, that means till the fourth step, what are the coins consumed? 4 into 4 plus 1, 5 divided by 2, which is nothing but 10. So the total coins we have is 10 and the coins that we would need till that middle step is also 10. So since we have found the logic, we will immediately return the middle itself. Okay. If at all, let's assume that if the total number of coins that we have gotten is 11 or 12, let's assume. In that case, here end is at 4 and start is at 4, but the total number of coins we had is 12, but the total number of coins that we would consume till this fourth step is only 10. That means that whatever the remaining coins that we have, it can go till the next step, right? So immediately we will update the start to middle plus 1. So start will be pointing to fifth step. But here we can no longer run the binary searching loop, right? Because we will only run as long as start is less than or equal to end. Since that condition is not going to match, the last step that we would fill successfully will be pointed by the end. So this is the case where I was saying that even after searching all the iterations, if at all if we couldn't find the exact number of steps, that means if the coins are not matching with the exact step that we can fill completely, in the end, whatever the end value that we have in the binary searching technique, it will be pointing to the last step that we can successfully fill in. So here end is pointing to 4 and fourth step, till fourth step we can consume 2 coins. In the fifth step we can put the remaining 2 coins of this 12. Okay, so those are the scenarios that you need to remember while solving the arranging of the coins with the binary searching technique. Okay, once again, very simple implementation. In every step, this formula is very important here. We will need to use we will need to know till the middle step what are the total number of coins that are consumed. So for that we will be employing the sum of the natural numbers problem, which is nothing but n into n plus 1 by 2. Here n is nothing but middle. So whatever the result that we get, we will compare with the total number of coins that we have. Based on the result, if it is matching till that middle step, well and good, the total number of coins are matching till that middle, so we can return that middle immediately. Otherwise, based on the nature of the value, either we search on the left of the middle or on the right of the middle. Okay. Now that we have understood this, let's quickly go ahead and write the pseudo code of this binary searching technique. Okay, so in almost all the problems I'm writing the binaries, I'm writing the pseudo code for the algorithm that we are discussing. So if at all, if you want to implement, right, all you have to do is write the logic that I'm writing in words into your programming language. Although most of the logic that I'm writing anyway is exactly similar to your implementation anyway. So try to pay more attention to the pseudocode part and try to write the implementation all by yourself. And if not, you can go ahead and check out the implementation videos as well. Anyway, here what we will do, we will write one function called arranging coins using binary search, or the function name is completely up to you. So here we will be taking the value of n from the user. Immediately we can have some basic check, right? If at all the value of n is less than or equal to 0, the total number of steps that we can fill will be 0 itself, because whenever we are taking the number from the user, there is a chance that user can enter some negative numbers, right? So for that we are simply putting this validation check here. If this is not the case, then what we will do, we will have to have start and end for the binary searching technique. So start is 0, end is nothing but whatever the given value of n. Along with that, we will be initializing one middle and initialize it with -1. Immediately, what we will do, we will run a loop as long as start is less than or equal to end. We will calculate the middle. Middle is nothing but start plus end divided by 2. Once we calculate the middle, we need to calculate the total coins consumed till this middle index, which is nothing but middle into middle plus 1 divided by 2. Once we get this, what we will do, we will compare the total coins with the coins that we have gotten, which is nothing but n. So here total coins, if it is equal to the n, then we are good. We can directly return this middle step itself, because that is the step till which we can fill the coins. If this is not the case, there are two scenarios, right? It can be greater or less. So if at all the total coins that we have got is greater than the value of n, that means we need more coins than what we have gotten in the end. That means that we need to find the lesser value. So here, that is the reason why end we will update it with the middle -1, as the lesser values will be remaining on the left side. If this is not the case, we'll need to find the greater value. So start we will update with middle plus 1. Okay, so that is the while loop. Now, like I mentioned previously, if at all the number is not matching exactly, it would not go into this matching condition. In that case, in the end, we need to return the end that we have, as it will be pointing to the last step that we have successfully filled. The next step of this end will be partially filled. Okay, so that is the binary searching technique specific pseudocode for arranging of the given coins with the help of a binary searching technique.